Satellites, rocket engines in the Holocene. This is my research. I was a researcher at the Aerospace Corporation for 36 years, and I worked in the Ivan A. Gating labs, as they mentioned. And now the USAF uses the Space and Missile Systems Center as primary launch responsibility for most of the operational satellites, like GPS, a lot of the weather satellites, and so forth. They launch out of Vandenberg, but the Aerospace Corporation is a nonprofit company that supports them with scientific know-how. So I basically worked in a stable of scientists, about 400 scientists in this Ivan A. Gating labs, coming from all walks of life. They were a very interesting group of people, very diverse. First, some background. All right, I'm only going to talk about facts today. A lot of people have a lot of ideas and things, and beliefs are fine, but I'm not going to talk about any of those. There's this guy, Elon Musk, who says we're going to Mars, and it's sort of a myth kind of a thing, but what I'm going to talk about is basically everything you know and love. You know, computers, vehicles, air travel, internal combustion engines, and so forth. So the sort of the macroscopic physical universe is governed by these things called partial differential equations, like that one. If this is too bright, is this dot too bright? Is it bothering people's eyes?
No, it's visible.
Excellent. Okay, so Navier-Cauchy equations, Maxwell's equations that cover electromagnetics, the Arrhenius equation, which governs chemical reactions, Navier-Stokes equations, which govern chemical flow. So these are facts. These are things we use to build the world that you're familiar with and that we all rely upon. That's the kind of thing I'm going to talk about. And I wanted to mention something else. I don't know if you're aware of ACRI versus New World Communications decision in Florida Appellate Court in 2003. Set a legal precedent, said, okay, the news, U.S. news doesn't have to tell the truth, basically. It does no wrong if it distorts the truth. Yeah, most people don't know about that. Canada has the Radio Protection Act, which says the news must tell the truth. So the U.S. news can't broadcast in Canada because of the... So it's important to know that what you're seeing on the news, there's no governing body saying that has to be true. So why is that dangerous when we're talking about things like facts? Well, let's say these are some temperatures you measured on a piece of wood out in the sun. Okay? Then you know there's an average temperature. You know how to calculate it. You add all the temperatures and divide by the number of measurements you made, and that gives you the average temperature of the piece of wood. Okay, well, nature invented that in the Big Bang. The mathematics of metric spaces, point set topology, physics of thermodynamics, and quantum mechanics. So we know why that works. Scientists can tell you why your common sense works. And it evolved as a part of the predator-prey problem. But yet, if you go to look at different news channels, there's no scientific foundation between watching a liberal and a Republican and then trying to draw an average opinion. There's no science behind that at all. There's no topology, no metric space. So you might fool yourself into thinking, gee, I understand both sides of this story, especially when it's legal for them to distort the news. So that's a dangerous thing to believe. And the last comment I have is the power of hidden facts. And people will use this on you a lot. Like, see three numbers, 1 through 5, their average is 3, right? And then somebody says, oh, well, there's some other number I don't know about, but it's probably close to the same, and so forth. Well, no, if you don't know that fact, it could be way off. So this is another way that the news can just sort of leave out a few important details. And again, the news has this way of tweaking things. And the last point is this. We've really entered the model age. Our models are excellent now. As an example here, the latest class of fast attack submarine, the Virginia class, was built entirely in a computer model. Ordered parts, brought them together in dry dock, put it together, and it was the first submarine in history whose maiden voyage had no significant reportables. This tells you how good our models have gotten. And the reason I bring that up is because I'm going to talk about climate models in a minute. That's known from my modeling. I mean, that can be reproduced. You need a supercomputer to reproduce it, but you know what's happening. Yeah, so now we're going to talk about the Holocene. And basically, carbon dioxide is the single largest waste product produced by the human race. There's some sources here: transportation, cars, ships, rail. but they can all be electrified. And if you can electrify something, then you can maybe use renewable power instead of the combustion of hydrocarbons. Aircraft absolutely require hydrocarbons. The energy density of jet fuel is 20 times that of a lithium battery. So we have no technology at this point that we're aware of, other than hydrocarbon fuels, that have any chance of, running a 747. Concrete manufacture. Concrete's the second largest, most used material by the human race after water. And when you make concrete, you release a lot of carbon dioxide. And of course, power plants. So here's a really cool classic. This is going back 450,000 years. This is a couple of different ice cores from Antarctica. And basically what we have here, temperature-wise, is hothouse Earth up here, which the Earth didn't spend much time there. It spent most of its time in ice ages. We're here, by the way, and there's the Holocene. But about 200,000 years ago, our species appeared in the fossil record. So we'll zoom up a little bit to about 100,000 years ago now. At this point, there were Homo erectus, Homo florenziensis, Homo habilis, Homo heidelbergensis. There were a lot of different species of humans on the planet. And us. And we weren't very different. Something happened right around here called the cognitive revolution, and they can see it in the fossil record, where we started thinking differently than any other human species on the planet. We tried to leave Africa here. They found settlements trying to leave through the Indian subcontinent that then just died out. The Neanderthals were already there, and they were bigger and stronger than us, had bigger brains actually. But they didn't think like we did after this cognitive revolution. When that happened, we left Africa and displaced all other species of humans. There was a little interbreeding, they know that now, and they don't know the details, whether it was a war or whether it was just out competition. It was probably competition. But we were the first large animal to cross open ocean to reach Australia. Within a couple thousand years, the megafauna was gone. About 20,000 years ago, we crossed to the Americas, and within a couple thousand years, the megafauna was gone. There was an oversized lion, mastodons, and so forth. And then this was in and out of ice ages, very turbulent time. We were always hunter and gatherers because you couldn't tell what one summer was going to be like compared to the next. But then if you want to believe in God, right there is about the most important thing that happened. It was the Holocene kicked in. Now nobody really knows why that happened, but it looks like the Earth figured out how to hold climate steady. Of course, the Earth doesn't think, doesn't have a central nervous system, and then all of a sudden, every summer is going to have growing season. And so what happens? We started off with agriculture, and then large-scale civilizations begin. So everything you know, everything around you, I'm going to talk about the younger Dryas there in just a second. But everything you know, everything around you we take for granted is because of that Holocene, where we have stable food supply, and we can start running the Earth like it's a nice, hospitable, warmed house for us. So the younger Dryas was one of the last big, quick changes. This is from White recently at the AGU fall meeting. Was finding warming on the order of 1 degree a year for 5 years, and then a stable period for 30 years, and then 1 degree C a year for 5 years. That's rapid warming, 100 times faster than what we've seen in the last century. I'll show you that in a minute. So now the question is, how quickly is this that we've kicked off? How quickly is that going to change? So, just some facts. So that's it happening there. We don't know how fast. This was January through July. We don't know what the future's going to hold. The models don't do that all that quick. But this is sort of an example. This is called a radar plot. Really cool animation I found online. This is 1 degree C cooler, 1 degree C warmer, and no temperature change. And then it's going to plot the months around the outside. So this is every month worth of data starting in about 1850. So I had some cool times there. There was a real hot set of months. There's 1900, World War I, World War II, my birthday, graduate from high school, and you kind of see it spreading out, and there's the turn of the century right there. And then 2016, 1 degree C. Big change, just fairly recently. This was done at the Hadley Center in Great Britain. They're one of the world's leaders. There's also a similar data set from NOAA and NASA. And this is what my generation is handing on to our kids. I have grandkids too. Done nothing for 25 years. We just fiddled around with crazy talk by talking heads on TV. And we went back to sleep and we thought, look, I got a new car. I should be happy. You know, that kind of thing. So now we're kind of in a pickle here. We're at 1 degree C. Here's another way of looking at it. So this is basically every thermometer reading in North America for these time periods here. And you can see the average. They're just piled on there. They're not even average. They're just all added together. So what's really important is here. You're going from no extremely hot days to a lot of them. That's like a quarter or a fifth of all days. And that's a problem because that's nonlinearity. What if that happens just before you're ready to pick your crop? And these are the kind of things we saw in 2016. You remember planes grounded because it was just too hot. The planes weren't designed to fly. In Great Britain and Australia, this is the kind of thing that can happen in a severe heat wave, and then they've got to go out and fix it. You can't bring food in by train when the tracks are like that. So that can be an issue. There's about 3 days supply of food in any city. Canada, Fort McMurray fire, 2 or 3 times the size of Prescott, just sort of snuffed by a wildfire no one could control, way too big. Melting asphalt, which would be another problem, I suspect, for Phoenix. I don't know where our food comes from, actually. But civil society has decided 2 degrees C is about the max we could probably tolerate and save civilization. This thing we've all grown to rely upon. Why not 4 degrees C? Well, there's a number of reasons. Can you imagine an 18-degree heat wave in Phoenix? You know, 140, something like that. Half the food supply goes away. I know we're rich, we're going to pay a lot for food, so it'll be the poor people far from here, people of color, who will be the first to get hit by this. But the IEA chief economist is saying 6 degrees would basically devastate the planet if it got 6 degrees average warmer. The IMF and the World Bank have come out stating that 4 degrees C would cause our civilization to break down. And there's a big equity problem too. 50% of the CO2 comes from 10% of human beings. The top 1% of U.S. emitters have CO2 footprints 2,500 times higher than the bottom 7 million people globally. So that's 3.4 emitting 2,500 times as much as the bottom 70 million. So what's causing this to happen? Well, here's an octane molecule. Think of your car has gasoline in it, about 114 atomic mass units, but when you burn it, it mixes with oxygen, and suddenly you've got 352 atomic mass units of carbon dioxide. So you can do your own calculation for your own car. 1 gallon of gasoline yields 20 pounds of carbon dioxide. So that's a pretty good rule of thumb to carry around. America in 2015, more than half of all Americans, there's 51%, are at the federal wage poverty line. 1% of Americans make $250,000 a year. They control something like half of all U.S. wealth. 1,000 Americans earn more than $20 million a year. But here's the clincher. The more money you spend, the larger your carbon footprint. That's called embedded carbon. If you buy something that requires a manufacturing process that releases a lot of carbon, then you buying that is actually releasing that carbon. But basically, it broadly scales with wealth. So the more wealthy you are, the larger your carbon footprint is. And so here's exactly who's doing the carbon bidding. This is the Chancellor and Piketty paper, 2015, came out right around the time. So there's 700 million people responsible for half world emissions. That's the top 10%. Notice North America here is half of that, about. So that's basically all the Americans. So basically, if you live in America, you're in the top 10%, give or take. I mean, there's some Americans here, okay? But the European Union has a lot more in this middle 40%. And then India, China has a lot of people down. But the bottom half of humanity, 3.5 billion people, aren't releasing any carbon dioxide to speak of at all. So I just got my ham license, and I was talking to a guy on the radio who drove a motorhome 1,500 miles thereabouts to a national park, dragging a Jeep behind it or whatever. And so I calculated he released about 6 tons of CO2. If 10% of all humans do that that's kind of a modest vacation, then that's 4 gigatons of CO2 released each year. So you can kind of see how these things we ignore. Now cars and trains can be electrified, and then we can use renewable non-hydrocarbon power. But air travel cannot be electrified. And this applies to daily work commutes and so forth. Over half of all humans, that 50%, can't even afford this kind of transportation. But here's a really egregious example. So this is analyzed by that Chancellor and Piketty stuff. This particular analysis was done by Professor Kevin Anderson. Basically, this guy here, private jet, private yacht, this is what we're talking about, embedded CO2. In helicopter, private island. So he has the carbon footprint of about 1,000 Americans, or 25,000 Zimbabweans. So every day he lives like this, he's telling 25,000 Zimbabweans that your life is heading for the toilet. Excuse my language. So that's kind of a problem, and that's how wealth plays into this. So we really need to look at the whole concept of wealth. If only 2% of Americans were like this guy, then that would come out to the full carbon budget of the planet. So, and of course the news doesn't tell you this, right? That's one of those large facts, the game changers that you're not told about. Who knows? Who knows what's actually going on with all that? I'm sure newsmen want their lucrative jobs, right? So they don't want to get in trouble. But so here's the IPCC carbon budget as of 2011. I'm going to explain real quick what a carbon budget and then try and finish up. So the IPCC is the Intergovernmental Panel on Climate Change. They're primarily responsible for collating the international scientific community's results on these. So as of 2011, these are the budgets we have, and right here, 50% chance of staying below 2 degrees C, saving civilization. We could release 1.3, we could release 1,300 gigatons more of carbon dioxide as of 2011. But it's not 2011 anymore, so now we have 800 and 1,000 that we can release. And I'm not going to mention planetary boundary analysis, but that's very interesting stuff. So what is a carbon budget? Well, let's say you release 5 gigatons per year, that's a rate, how much you're releasing, for 5 years. Well, that's 25 gigatons. So you release, and then you stop releasing carbon and never release it again. Then you say you've released 25 gigatons. It's actually the area under this rate curve. This is the real world now. These are the various climate change. We knew way back in 1990 what we had to do. We haven't done anything. You can see the rate of release keeps going up and up and up. How much carbon do we have to release? Well, we have an area. We can't change the past. That area is fixed. But what we do with that area, the amount of carbon budget, remains to be seen. So we need that to be less than 1,000 gigatons. Right now we're heading in this direction, and this is one of those cases where I'm not going to call that a fact, but I will point out that this is my belief. 6 degrees C is associated with the end Permian mass extinction. When the Siberian traps, a large igneous province in Siberia, belched forth for 1,000 years and raised the carbon dioxide, they believe it raised the temperature of the planet about 5 degrees C. And then runaway feedback loops took over. So if we do this, have all this area, we're heading for basically a global kill event by 2011. Now that area I mentioned, if we want to stay below 2 degrees C, this is about the gentlest you can hope to do with it. In other words, you have to stop emitting carbon dioxide very quickly and start tapering off essentially to zero. That's where we're at now. The Paris COP21 was closer to 3.5 degrees, even though they pretended it was 2 degrees C for political reasons. But we've released so much carbon dioxide now that we have no alternative except to make rapid deep cuts now, within the next 5 years or so. We have to turn that curve over and start heading it down. So what does that curve look like? 5 years isn't enough to build a whole bunch of new nuclear plants or wind power or solar cells or anything like that. There isn't enough time. The only way we can stop emitting is to stop emitting. And then later on, if we get low carbon energy in place, then we can raise our emissions again. But if we wait till, if we had started in 2011, we would have had to reduce in about 4% a year. So can you imagine 4% less gasoline every year? You can do the math. That's unpleasant. Well, now if we wait till 20, then it's 10% every year. 10% fewer airline flights every year. 10% less heating of your house unless you get a really good heat pump system. 10% fewer car trips until it hits zero around 2040. By then you've got to have electric and you've got to have other things. Buses, rapid transit, whatever. So this stuff took like a couple of years before I could get it into my head. I was just so used to the scientific world I lived in. This laboratory that sucked power, you know, in order to keep all these millions of dollars of equipment going. And the other problems I mentioned. So I could take an early retirement. I did. I had enough money to buy a little house out in the boonies out here. And I've got my carbon footprint down to about half of the average American footprint. But we need to be down here. This is what's going to save civilization.
Excuse me, Patty,
Sure.
I can't see that website. Can you?
Oh, I'm sorry. www.carbonfootprint.com. Yeah. And there's a lot of different ones on there, and they go with a lot of different assumptions. Or you could download some scholarly literature and do some actual calculations. But a lot depends on where you live. Just living in America is a huge, you saw most Americans are, even the poor living at wage poverty are emitting so much more carbon than the rest of the world. So how has this gotten out of control? Our generation has ignored. We've listened to talking heads for 25 years. It's been well documented, Oresky's and Conway's books, how that came to be done. Politicians, they'd be kicked out if they got up here and told you stuff like I'm telling you. Thankfully, I'm retired. You can't fire me. Scientists have been defunded. Yeah, they were defunding me if I didn't tell them that the SpaceX rocket was clean as a whistle. No worries. And scientists are really just ordinary people. They want to be wealthy. They want to fly to their conferences. They want to go places and, you know, be part of the jet set, this modern world that we've all learned to take for granted. Problem is, this snuck up on us, and we weren't really prepared for it. Another thing I've run into a lot with older scientists, Einstein was an example of this. He went to his grave thinking that quantum mechanics was garbage. But aging monodisciplinary scientists have been known to have trouble accepting new information. So you'll see a lot of these old guys getting up there and actually saying things that are wrong because they have a vested interest in their old theories. Also failed economic theory and political and shareholder profits. Corporations have been 50, 60, 70% profit taking rather than reinvesting it into new structures and so forth. So this is all stimulated by affluence or the desire for affluence. So it's literally affluence-induced climate change. Yeah, so just where are we headed? And this is the latest thing from the IPCC AR5. This has really shocked a lot of people, international corporations, the reinsurers who guarantee all our insurance work. Basically, right now, given where we're at, which is 450 parts per million CO2 equivalent, we're going to come, there's about a 1.5% chance that we'll come to an equilibrium of 6 degrees C, which, as I mentioned, is a global kill. Well, what does that risk mean? What does 1.5% mean? Well, if there was a 1.5% chance that airlines would fall out of the sky every day, then you'd see 1,500 airliners. Would you even get on an airliner if you knew that day and every day 1,500 were going to fall out of the sky? Yeah, but we're doing this with our planet. 7% chance of 4 degrees C, which means civilization is over, but it probably won't be a global kill at 4 degrees C. So yeah, this snuck up on us real bad. Although there were people 150 years ago who knew this was coming, but it's really hard to get consensus when you've got people, because people like to cheat each other. People like to play tricks on each other. They want to get money away. I don't know if you ever haggled with somebody and they haggled you back and forth. Anyway, so some direct Prescott effects. This is soil moisture. Prescott is right there. This is now assessed out of the AR5 data sets. About 17 different climate models were assessed for this. So we're like at a 90% risk of a decade drought within the next 50 years. I'm not sure how long I'll be here, meaning alive. But above 80% for multi-decadal, which is a 35-year drought. Now, scientists tend to be conservative. I'm not sure I think they're being overly conservative here, because a drought is something that ends, right? Everyone talks about a drought as something that ends. And here's some historical droughts that have happened as the moisture balance decreased a lot. But this is a complete game change here. It's not recovering. This is a new normal. So they're calling it a drought, and the title of the paper was Unprecedented Drought Risk. But that may be disingenuous a little bit. But again, these are models. We don't actually know until we go there. But luck favors the prepared. Here's another recent paper. Arizona is right there. Basically, stationarity is the principle that all water managers have always used, that you have a climate like the Holocene, and things wander around, and you prepare for your worst case and your best case. Well, everything's changing, so stationary is dead. Anybody who knows the water managers at Prescott might want to have this conversation with them, because they may or may not have been trained in water management, but if they have been, they were trained in stationary water management. And they need to be preparing for what we're going to see. Okay, so the Holocene is here. Everything depends on the Holocene. We want to stay there, but we don't know if we can. So we're in a climate emergency. This is not a message of futility, but a wake-up call of where our rose-tinted spectacles have brought us. Real hope, if it is to arise at all, will do so from a bare assessment of the scale of the challenge we now face. Ultimately, we must escape the shackles of our 20th century mindset if we are ever to resolve the 21st century challenges. This will demand leadership, courage, innovative thinking, engaged teams, and difficult choices. And we have a lot of really good teams here in Prescott. And it may be time for us to begin to talk to each other and work together and see what kind of changes we can begin to make. Robert Unger, you may know, philosopher, politician. At every level, the greatest obstacle to transforming the world is that we lack the clarity and imagination to conceive that it could be different. I mean, what we see is this world we were grown up in, which is going away. So what can we do? Well, there are compelling reasons to halt nearly all commercial air travel. Stop using dirty rockets. We just can't, we have no idea how to electrify aircraft at this point. There are compelling reasons why people who make $50,000 or more a year have to cut their carbon footprint very quickly. And we want to do this in as coordinated a way as possible. So my thinking is town hall meetings. Trying to think out of the box, building local resilience, town hall meetings. I may be running out of time, so I'm just going to blow through this slide. But I wanted to show you this. Hydrocarbon fuels must go away and fast. How about some electric buses for our highway out there? Now that's like everybody goes, yeah, sure, why not? But it's like, can you conceive of that? And this is what I mean. So 10,000 Prescott women, and grandmothers and mothers who care about their children and grandchildren donate once per week the cost of a latte. That's $2 million in a year. You didn't know you had that kind of money, did you? Okay. You could probably afford one latte per day. That's $14 million in 1 year. That'll buy 14 buses and pay the drivers. Electric bus gets about 400 miles to a charge. So this is me trying to think out of the box. And if they make their husbands do it, we can get $30 million. But I mean, there are other things we can do. This is just an attempt at thinking creatively out of the box. And we have tremendous knowledge shared between ourselves on this sort of thing. So the most important thing is to learn to think differently and begin to imagine possible new futures. This wouldn't require our city council at all. I mean, we could do it as a nonprofit corporation. I mean, teach this to our children and grandchildren. This is a college town, but the college town doesn't talk to the retirement community. The retirement community doesn't talk to the college. So it's a little bit fragmented. And there will be tough social problems in trying to do any of this, which an all-inclusive, everyone, town hall approach may help resolve some of these problems. But it's going to be hard, and this is why courage is required, because it's hard. Whatever the future holds, it will not look like the past or the present, but we do have choices. So our civic leaders can do a lot. They can increase support for local food, local businesses, instead of giving free land and hookups for large corporate stores that we don't necessarily need. Local resilience building, instead of building new houses, you can retrofit existing houses so that people who don't have money or people who are struggling, we can actually live a better life. Develop legal options for local investing. Because every time we buy locally, our money has a multiplying effect locally rather than shipping it off to Wall Street. There are electrical cooperatives in this country where many counties own the electric company, and they all run it like a group. Out where I am, it's the Diamond Valley Water District. It's a bunch of yahoos like me who figured they could run a water district, and they're doing it. This can be done with a lot of different things. Rebuild, repair, reuse programs, the maker movement. Develop science-based water policies. Of course, I'm poking at the Prescott people. And we can do all this if we choose to work together, but it's our choice. And it's not necessarily easy. So I think this is my last slide. But there's a lot of information out there. Here's Johns Hopkins Center for a Livable Future, University Press of Kentucky, Yale University Press, Fellowship for International Community. Here's a really good book. I actually have a copy if anyone's interested in reading it. What I found hard there, I like science, I like equations, I like experiments, but this talks about how do you get people to work together, especially when they're yelling at each other in the middle of a meeting. That takes real courage and strength. But those are the kinds of things we're going to need. Anyway, I have a copy of that book. I highly recommend it. It's very diverse. I don't know if you remember from grade school, you had a reader.
Yeah.
And, you know, there'd be like a science fiction story. There'd be a novel. There'd be some poetry. There'd be all these different things. That's why that's called a reader, because it has many different things in it that all are going about building community resilience. We probably don't want the feds telling us how to run Prescott. They don't know in the first place, and second, we're not sure we agree with them. But Arizona State University is granting a master's degree in community resilience, so we do have resources. Our own Prescott College has a Master of Arts in Environmental Studies and Sustainability. So we can start working these things together. But I was in Wild Iris the other day, and there was a professor there grading paper, an engineering professor. I said, did you read the IPCC AR5? Did you know there's a 1.5% chance of a global kill? And he just sort of goes back like that, and he says, wow, that's huge. Because he's an engineer. He knew what 1.5% meant. But he didn't know anything about this. So he's educating these kids. And these kids are going to be like me. They're going to grow up and not know anything about what they're actually facing.